are frequently charities or NGOs, so to help them learn what kind of data science techniques are available and how they can use their data. And finally, it's to build a community and a network, which can be very helpful afterwards when looking for jobs or looking for other social good type data science projects. So in 2017, this was done at the Nova School for Business and Economics. So in my team for this project, there was myself, Ivan and Shubham. We were the engineers and data scientists. We had a technical mentor, Jane, and a project manager, Paul, and we got advice from Nishan at the World Economic Forum. So we were fortunate that we had Nishan had a lot of connections and was able to get us some really interesting data sets and get us exposure to some quite powerful people. So for the DSSG summer fellowship projects, and this Gantt diagram is quite typical for data science project, going through 3 phases from project scoping, which is actually when we start the summer fellowship, this is sort of half done for us. So this is trying to figure out what are the reasonable expectations of the project. The data collection phase, you might have to work with your partner organization and help them perhaps extract what's needed from their databases. Data cleaning, which is usually takes more time and more difficult than imagined. I mean, there's often data scientists say that 90% of the job is just doing data cleaning. And then, in this first phase, you might also do some descriptive statistics or some basic plots to get familiar with the data you've acquired. So the phase 2 is typically where the machine learning or predictive modeling is done. And you might do many iterations of this to improve your model and split your data to prove to show the effectiveness of your modeling. And finally, you identify some use cases and show a path to implementation. So in my mind, I split this. This is a typical kind of data science workflow, or like a life cycle of a research project in data science. And then what I've seen in industry is, from the insights and modeling you do here, you would probably, if all of these stages are successful, then there's a whole other step where the machine learning engineers and data engineers will be looking to productionize your model and scale it and get it deployed at a larger scale. So to the problem at hand, as many of you are probably aware, our oceans are not doing so well. There are a whole bunch of problems, from acidification, degeneration of coral reefs, unsustainable fishing, and overexploitation. So we've seen massive declines in tuna populations, for example, which are very important because they're an apex predator in the sea. So there are many issues to be worked on here, and illegal, unreported, and unregulated fishing is just one of those. So this was the subset of kind of ocean problems we were working on. And so I'll refer to that as IUU fishing from now on. So that basically means extracting fish from waters of other nations or marine protected areas where fishing shouldn't be happening. or catching fish using illegal or damaging techniques, or engaging in practices like transshipment, which is basically where one vessel tries to offload their catch onto another vessel so that they don't have to report it when they return to the port. So this is a massive problem globally. It's particularly bad in Southeast Asia. So yeah, we wanted to see whether we could use new data sources from satellite imagery and radar to combine with data science methods to try to identify vessels that were engaging in these IUU type behaviors. So it's quite an opportune moment to be working on this sort of problem, not only because the machine learning techniques and the data science techniques have improved, but because we now are acquiring much more data on the oceans. So one source of data that's quite new is from these small satellites called CubeSats, which are being launched and put into orbit at a high frequency right now. So there's a lot more image data available than, say, 10 or 15 years ago. So our approach to this IUU fishing problem was to use these new data sources and create a combined IUU risk score. So looking at things like the likelihood that a vessel has been fishing in a marine protected area, or looking for strange behavior from the vessel, like intermittency of the vessel's AIS signal, which is their radar location. So sometimes that can be an indicator that the vessel is trying to remain incognito and not be tracked by other vessels and maybe engaging in illegal behaviors. So yeah, this we wanted in the 12 weeks, which is quite a short time really to be doing a project like this, to create a proof of concept to show what sorts of things could be done with these data sets. So our end goal was to have something as a web app where you can set weights based on these different IUU behaviors, these component weights at the top. You can select a region of interest and see a list of vessels sorted by their likelihood to be engaging in illegal fishing type behaviors, and then to get information about any selected vessels. So potentially the Coast Guard or enforcement agencies can intervene at this point. So for this project, we had collaboration with 3 satellite companies, Spire, DigitalGlobe, and Planet. So Spire provided us with this radar data, which was pretty phenomenal. It was gave us all the locations of vessels with radar for 2 years. We also had access to DigitalGlobe and Planet Labs APIs, and these are 2 satellite imagery companies. And we also had support from the World Economic Forum with our advisory, our advisor there, Nishan. So AIS data, which was the main data source for this project, is it's mainly used for collision avoidance of vessels. I think it's a legal requirement within 200 kilometers of the coast that vessels have AIS data above a certain size. But many fishing vessels, especially in less economically developed areas, don't use AIS data. So we acquired 2 years of historic data with over 500,000 vessels that from our collaborator Spire. So you can see this is a visualization of the actual data we were using, and you can see the global shipping routes there. So a lot of the vessels in the data weren't actually fishing vessels, but you can see, for example, in Southeast Asia, a very high density of AIS signals in that heavily fished region. So we had a pretty big data set there. We also had access to Planet Labs, which is a satellite imagery company that was set up, I think it was in 2007 in San Francisco, and they launched these cube satellites like you can see on the left here. So we had access to query their set of images as well, and you can see the kinds of imagery we were working with and the resolution, and a set of vessels we found in those images. So we also had access to DigitalGlobe, which is a more established kind of old school satellite imagery company, which has high resolution images, but a lower frequency of imagery. So Planet Labs actually aims to image the entire planet every single day, and they have I think they now have launched hundreds of satellites, and they work they use SpaceX rockets to get their payloads into orbit. So there's more and more image data becoming available sort of all the time. They're improving their service there. So we were quite excited to be working with Planet Labs, especially because of the high frequency of their data. So our first challenge was to see how useful is this satellite imagery. And having these three massive data sets, we didn't really know where to start. So we decided to look at the Torres Strait, which is an area between Australia and New Guinea. It's about 180,000 kilometers squared. And we did a kind of study of the satellite image data we could acquire there from both Planet and DigitalGlobe. So we found basically that there was most of the coverage was, as you would expect, over land areas, since these companies, there's not much economic value in photographing the sea, which is what we were interested in for this project. So you can see on the left, this is a year's worth of imagery from Planet, and the same thing from DigitalGlobe on the right, which has less coverage. So we also wanted to see, can we intersect this satellite imagery data with the data we get from the AIS or the radar data of vessels, and sort of correlate them in time and space. So we were able to do that in DigitalGlobe, but only found 487 vessels by their unique MMSIs, which is like a unique identifier for the vessel. So these are some of the intersections we found, and there's a whole like variety of image restoration and pre-processing techniques applied. So and the images have different resolutions, so sometimes it's quite hard to spot the actual vessel, other times it's much more obvious. But yeah, these are some more example images. So when we use the intersection of the satellite imagery and the radar data, we can get information about the, in the radar, we have information on the flag, the country the ship is registered. the ship type that has a name and an MMSI, but these data are frequently missing or inaccurate, and many ships try to kind of hide their identities. And these are some images from like a trace of a fishing expedition around the Torres Strait, and we were able to find the vessel in satellite imagery for a couple of different vessel trajectories here. So yeah, in this stage, we wanted to show that these data sources could be combined, and that satellite imagery could be useful in looking at this problem. So, but in the end, we concluded that because the coverage of the satellite imagery is mainly over land, it wasn't so useful for exploring these problems with illegal fishing. And even the very high frequency data that's now coming online with Planet Labs is not really sufficient for tracking a vessel. So even if you have once a day, it's difficult to find the vessel. And of course, with satellite images, cloud cover and low resolution is still a big problem. But the hope is that as more satellites are launched and the APIs become easier to work with, and perhaps the restoration techniques improve, that satellite imagery could be a useful secondary data source. So this is a flow diagram of the approach we took, given what we found on satellite imagery. So you can see at the bottom, well, these are the different data sources. In green, we have the satellite imagery, which we decided wasn't useful for our main goal of identifying illegal fishing, but we could still use it to intersect for vessels we have in the AIS data, and provide like visual confirmation of what we think are illegal vessels. So what we did was take the AIS data, construct a bunch of features based on the movements of the vessel, like the standard deviation of the change in the vessel course. And we trained a model to identify behavior that looked like the vessel was fishing. So in this flow diagram, you get this. If the vessel, if we don't have, if the model doesn't predict it was fishing, we're not interested. If we see fishing type behavior, we then look for evidence that it might be involved in illegal fishing behaviors, and construct a component risk score. So yeah, we start with generating features like the distance to shore, distance to closest port, the course of the vessel, the speed, the sunlight or the time of day. Then we split our data into a trained test set and train a model to recognize fishing behavior. So we did this by sort of hand curating for vessels that we knew were fishing vessels, and training on the unknown set of vessels. So we could recognize, this is a very simplified view, but some of our features would represent more fishing type behavior, like this sudden changes in course of the green vessel compared to the blue vessel. So that's the kind of thing the model would pick up on. And then if we saw the vessels were fishing and in areas they shouldn't be fishing, like these marine protected areas, then we flag that as one of the components in our risk score. So we also looked at fishing when a vessel is fishing in the exclusive economic zone of a nation, which it's not registered to. So each country has a 200-kilometer sort of boundary which they're allowed to fish in. And so we look for vessels that were fishing in other exclusive economic zones from those which they were registered to. We also look for behavior like transshipment, which is, as I mentioned, the offloading of cargo, which often happens far out at sea and is a big problem. So that vessels can underdeclare their catch. So that what they do there is two vessels will sort of dock onto each other and offload the cargo to another vessel, and maybe take it to a different port to the one the vessel should be returning to. So we wanted to combine these different risk scores and create a component risk, the sort of a total risk score with different weightings. And if we could, we would provide visual evidence of the vessel as well by querying the DigitalGlobe and Planet APIs. So in the end, the tool we created looks something like this, with a list of vessel IDs here on the left, the last seen timestamp, the country where the vessel is registered, and some different indications of these different components of the risk score. So the idea here is that an enforcement agency could then know which vessels best to inspect. So yeah, that's more or less it from yeah, so we wanted to demonstrate the sorts of things that could be done with this, and the hope is that a major retailer might take this up and use it to verify the vessels from which they're sourcing their fish not involved in IUU type behaviors. Could also be a useful tool for local enforcement agencies to know which ships to target, and it could be also useful for finding where IUU hotspots are and which high-risk ports there are. So I think, yeah, that's it for the talk. There are a couple of other organizations working in this area, as well as DSSG, Pew Trusts and Global Fishing Watch, which is supported by Google. So yeah, that's where we got to with that project.
Nice. Really nice, Will. Thank you really so much for sharing your project. Actually, you know, the illegal fishery topic, at least for me, like I think it's a topic that became quite popular recently with many articles and information and stuff. And there is one specific thing that I think that boomed, and I don't know if you guys have watched it, Seaspiracy, the Netflix stream documentary about illegal fishery. I don't know about the credibility, let's say, of the data, that the information that I've spread on the documentary, but still, I think it was kind of one of those things that started spreading then the whole information about illegal fishery. I do have a couple of questions for you, Will, but I don't know if anybody else also has some questions about the project, about Will's experience or any kind of curiosity. So I was wondering if anybody has any questions and would like to share them with us right now. If not, I can break the ice and ask some questions.
One thing I was curious is,
Okay.
if you let me, sorry to jump in. Was in terms of the data that you had, how balanced was it in terms of, you know, phishing and non-phishing behavior? Did you have to use any balancing technique?
I think I mean, so it's been a while, so I'm slightly struggling to remember this.
No problem.
I
It's
mean,
not critical.
in the AIS data, the majority, I would say, was from irrelevant sort of cargo ships and transport vessels. So some of that we could exclude. I think most of it we could exclude straight away. But I mean, our model was, yeah, I can't remember the class balance for the remaining data, I'm afraid.
Thanks, you.
Good. I have a question. I don't know if it's pertinent or not, but you basically at the end, you showed us this web application that could have a benefit for different organizations, institutions, private. So is the web application, is it live right now still? I know that the project is has a couple of years already. It was designed in 2017. Like the platform is still live and keeps on being updated? Yeah,
I'm afraid it's not being maintained right now. So we tried to keep it going and really struggled to get funding to continue a project like this, which, and maybe it's a bit different now, but in 2017, it's difficult to find organizations that are willing to fund such a thing. I mean, it's such a global problem and the magnitude of it's so big, but there wasn't much awareness back then. So yeah, unfortunately, it hasn't been maintained. But you know, I've actually, since completing that project, I was contacted personally by people who are looking to do similar things, and we've had contact with Global Fishing Watch and the Pew Trust. So I wouldn't call it a failure in that regard. I mean, we always hope to, if you wanted to apply this at scale, you'd need probably a much larger budget and more time and resources, but we hope to sort of just demonstrate the concept here.
Sure. Melinda has a question here. Melinda is asking about the project. Was the hardest part of the project, and what was the most fun part of it?
I think the hardest part is probably actually the scoping part. Like in the 12 weeks, we were lucky in the sense that we got access to 3 huge data sources from 3 different companies, and they all had different APIs. So it was quite a task to figure out what was useful in that data and how we could use it. So I think probably we probably spent half the time just trying to understand the data we had access to, because there was so much of it, which meant the remaining sort of 6 weeks of the project, we had a lot of pressure to actually do something useful with it. So I think that was the hardest part of the challenge. For me, the fun part was I really enjoyed having access to this satellite imagery and to be able to correlate the AIS data with the satellite imagery. I think there's just something quite astonishing about being able to have images of the vessels. and also knowing that this satellite imagery, it could be more and more useful in the future.
True. I think it's pretty amazing. Like the data that you have been working with is quite astonishing and impressive. Going on another topic, maybe we're still talking about projects in general. I have a question. We already had a talk before we got to know each other, and then you mentioned some projects, some additional projects that you've been working on, still related with data science and positive social impact, let's say, or an impact on communities. I wanted to ask you if you could tell us more about it or about them. If you could mention, let's say, some other cool projects that you are being involved in.
Yeah, sure. So I can give a sort of synopsis of my work life since I finished my PhD. In 2016, I finished a PhD in bioinformatics at UCL in London, and I saw there was a lot of hype around data science, and I went to some talks and realized that this was a good place to apply my scientific skills. So I joined an organization called ASI in London, and they have it was sort of an internship, and they have affiliations with a bunch of different companies, mainly in the UK. And I saw there were a lot of projects to do with marketing or improving sales, and I just frankly wasn't interested in doing that. And I think many people, so many of my colleagues there were quite happy to do those sorts of projects, but I just didn't want to. Whatever reason, it seemed a bit pointless to me. I mean, there were things like at Tesco, the supermarket, building a recommendation system to recommend items for somebody's shopping basket. Or there was a project with EasyJet, the airline, to find to predict which components of the airplane would be should be checked the most frequently. So things like this, which are of course important, but I didn't. It wasn't that interesting to me, and they were sort of mainly motivated by optimizing a process to save money for a company. So that was the situation at least in London when I was looking back then. And I saw there was a project with the London Fire Brigade, which I did, which was, it was an NLP project using topic modeling so I had access to the corpus of fire reports from incidents in London, and it was to find the different, to use these reports and find the different kinds of fire scenarios that were not known about previously to the fire brigade. So these were things that weren't really well captured in their database, but were in the fire reports. Like so we found things like fires in high residency, occupation housing, and actually a lot of cannabis factory fires. So yeah, we were able to kind of use topic modeling to find previously unknown fire types. And after that, I got involved with DSSG, which is where I did this fishing project. And then through DSSG as well, I I did a project in transportation and subsequently joined a startup called Numerico, which is, and I've been working the last couple of years on a product to deploy traffic inspectors in the Netherlands on the highway system so that they can respond to incidents in the least time possible. So yeah, I mean, I've been fortunate to have found some interesting and I think meaningful projects to work on, which was important for me. And actually now I'm also getting involved in a startup called New Mind, based in London, that helps people with traumatic brain injuries. So it's an app that helps them in their sort of daily lives, helps them to sort of do things like basic things like remembering to brush their teeth every day. And it has a series of memory challenges to help them improve their cognitive abilities following an accident and rehabilitate. So I'm working on a project there to like identify different types of users of the app and like customize their experience and give them prompts at the best times and most relevant to them. So yeah, those are the sorts of projects I've been involved with.
Nice, nice. And I find it always, once again, I tell it every time that I'm hosting a data science event. I always find it so fascinating how data science can have so many applications in pretty much everything. And in this case, how data science, data analytics can actually have an application on many different things and projects that can actually have a positive social impact. You know, normally we always look at data science as projects like the ones that you mentioned in the beginning for big multinationals or big companies, either Tesco, EasyJet, like the ones that you mentioned, that are more focused on sales or improving customers' excellence and so on, you know. And well, actually data science can have so many more applications. I don't know if,
I think it's possible to have both, like a good financial incentive for a project and have a meaningful impact or a social good impact. But of course, all the things with a high financial impact come first. And I think really like the last 10 years, data science has become sort of an emerging job area or area of industry. So the projects with the highest financial impact tended to be the ones done first. So I'm kind of hoping that now there may be more room for other kinds of projects, like second order projects that have more good social impact as well.
Of course. I mean, what you said right now about data science and the priority, let's say, to financial projects and so on, I think it's a thing that, yes, it can be applied to data science, but pretty much anything right now. But like you, I'm hopeful, let's say, that there will be more room for its application to other projects with an impact.
Yeah.
I don't know if anyone has another question or doubt or any curiosity. Nuno? Nuno, Mariana?
Oh, Mariana, go ahead.
No, I really don't have any questions. I just wanted to congratulate Will for this project and for the kind of projects that he's been choosing to get involved in throughout his career. I think it's truly inspiring to see people such as yourself using their really advanced knowledge for good. So thank you for that.
Yeah, thank you very much. Yeah, that's nice to hear.
Yeah, my question was related also with what you've been saying and all of these projects, and it relates to what is the process that you follow to sort of understand these different data sets, because like we've been talking about, you know, from phishing to, you know, recommendation systems for grocery shopping, and these are really obviously different data sets, different goals. Like, how do you prepare, or what type of functional support you need to be able to understand those data sets and how to make the use out of them? Because if you'd ask me, if you'd give me the data sets that you use for this project, I would have no clue how to understand if a boat is fishing or not, if a vessel is fishing or not. So it's how do you get to that level where you are comfortable enough to understand how to take information from like the data and what it means on the business context. Or so.
Yeah, I mean, I think that's often the hardest, well, one of the most time-consuming or difficult parts of a project is to get the required domain knowledge to solve a problem. And I think that's where like having a scientific background can be really helpful, because you kind of have an intuition about how to handle new data sets, or what kind of plots you might need to make, or what statistics you might want to see to try to understand it. And yeah, sometimes, like in this project, as I mentioned, the actually understanding the data and working with the APIs was quite a challenge. But in other cases, like so the company I'm working with now that I mentioned, doing this brain injury rehabilitation, it's a startup with 2 engineers. And sometimes I think ignorance can be a virtue, like asking the basic questions, rechecking assumptions about the data, making sure it's like understood what it means and what it represents. I think that can also be very helpful. So yeah, that's but it's yeah, it's a sort of double-edged sword. Sometimes I think it's a bit like you can be a consultant going in trying to ask the naive questions and check assumptions, and sometimes you need more domain knowledge. So yeah, it depends on the projects, really.
Thanks, Phil.
I think Tim has a question. Go ahead.
Thank you. So also from me, thank you very much for sharing to me very interesting field of application for data science. Yeah, and so I'm an undergraduate student. I study business, and I'm interested in actually doing the data science course with Wagon this summer. And I kind of the statement that you just made triggered me that a scientific background enables or makes it easier to become active in data science. Since I'm also thinking about if a PhD might be sensible to me, and maybe other people here also have similar questions. Can you explain why you think that a scientific background helps in data science projects?
So for me, I think having some intuition about like the scientific process and how you sort of evaluate a hypothesis and what sorts of hypotheses it's fair to make is useful. But I would also say, I think for the kinds of projects I've been involved with, being a generalist is very useful. And like I've seen many of my colleagues come from all different backgrounds and sort of be very useful, and maybe coming from different backgrounds can also be an advantage in seeing things differently. So I think, yeah, I wouldn't let that put you off too much. During my PhD, I did a lot of image processing, and also for this project, I used those skills, but since then my path has not involved that work at all. So Yeah, I think there are just so many different paths you can take in data science, and there's not a right one or the best one. I mean, some people will do a very specialized PhD on particular new deep learning technique, and they might be one of the best in the world at that, but not have some of the other more general skills, or not interested in applying their skills to these sorts of projects. So yeah, I think there are just so many different ways to navigate this emerging market, and there's not a right answer here.
Thank you.
Thank you. Does anyone have more questions, doubts for Will?
I might
Yes,
have
no.
one.
Okay, yes.
From my side as well. Sorry.
Hi, Charlotte.
Hi. Thank you very much for the interesting talk, Will. I was just wondering, are you still involved in or a member of some kind of organization that still undertakes like or discusses social impact projects like DSSG?
Loosely, I mean, so Chiwei, who contacted me to give this talk, is involved, and I'm still in contact with many of the people I met through this experience, which has been useful. It's been very useful to have a network of people when it comes to job opportunities and so on. But I'm not directly involved with the DSSG organization at the moment. Yeah.
Thanks.
All right, thank you. But I'm gonna be asking you then a thing that is pretty much connected to what Charlotte asked, kind of. If you would give any tip or any suggestion to someone, to a young data scientist, or to someone that is a fan of data science and would actually like to get to know more this aspect of combining data science with sustainability, with social impact, can you recommend any other organizations or sources, or I don't know, data sets that you can find online that are connected to this?
Yeah, so I actually think I've got a few things. DataKind is another organization that works a lot with charities and NGOs. I think they're based in the UK, but you can volunteer with them, and probably many people know Kaggle as well, which is good for improving your skills, and they have some pretty useful kinds of projects.
What was the second one that you said again? DataKind and the other one?
DataKind and Kaggle. I mean, probably
Kaggle.
most data scientists will be quite familiar with this, and they have a whole bunch of different projects. I actually did a project on Kaggle to do with fishing as well. I've done a project on here for image segmentation of cancer cells. So they have all sorts of different competitions live. But what's nice is it's a competition, so you can submit your model and it gets evaluated against some data sets, and there's a ranking, so you always know how you're getting on there.
Cool, lots of nice information and inspiration, let's say. I think we are almost coming to the end of this really interesting, let's call it presentation, talk, a really different, nice story and take on data science. Last call for any questions, curiosities, whatsoever. Anybody? No, I'll take it as a no. But I think we have been seeing quite many information and insights today regarding this event. This event is being recorded, so I'm going to be sharing with the participants a replay if you want to watch it again, if you want to take a little bit more inspiration. Yes, so tomorrow I'm going to be sharing the recording. Just to give you a sum up of the data impact school. So this one is the end of week 1 about environment. Next week is going to be week 2 about gender equality. First meeting that we're going to have is the workshop on Monday on gender equality. We're going to be having a known face for the ones who have been participating in the data journals, Isabel Fonseca, who is a data scientist in BNP Paribas here in Lisbon, but is also a teacher at Wagon, the data science bootcamp. She's going to give us a workshop in machine learning using a data set that is related to salaries and gender equality. And then on Wednesday, it's the talk day. We're going to be having pretty much the same structure as today, still on Zoom. And I'm going to be sharing the link with you per email. Pay attention to your mailbox. It's again going to be a talk, but this time with many different people, different female data scientists working in the tech scene in Portugal. They're going to provide their testimony, their story, how they work. And we're going to have a look at different insights about gender gap or gender equality or inequality, let's say, in the tech and data science sector in Portugal. Thank you again, Will, for your presentation and for sharing your story, first of all. And thank you all for taking part to this second event of the Data Impact School. I hope I'm going to be seeing you in the following events, and have a really nice evening. Bye, everyone.
Thank you very much. Have a nice evening.
Thanks.
Bye-bye.
You too.
Thank you, Will.
Bye-bye.
Bye.
Bye, bye, bye.